Okay, this is the second video segment for solution to homework number 21. Now I stopped at 33, problem number 33, and problem number 33 was z equal to 2 root of 3 minus 3i, minus 2i, and we are asked to write a polar form, but the argument theta we want it to be between 2 pi and 0, because remember, argument is not unique. Anything that you get, you can add 2 pi to it, still argument, but we want the argument to be here in this problem 0 to 2 pi. Okay, so that's very simple. First of all, it is helpful if you located this. Let me see now. If you put some tick marks here, the real part is 2 root 3. Now, 2 root 3 is 2 times root 3 is approximately 3.4. So we're talking about, this is your 3, this is your 4. 3.4 is somewhere here. This is 2 root 3, somewhere there. And then the imaginary part is minus 2, so you go down. So right there. So this is your z. Now, having said that this is your z, you connect this to the origin. There is your modulus. So the modulus is basically that hypotenuse, which is 2, let me write that out, square root of 2 root 3 squared minus, or plus, sorry, plus minus 2 squared. And this is equal to root of, okay, so this is 4 times 3 is 12. Plus 4, oh, that's 4, that's nice, root of 16. So r is equal to 4, very good. Now, the angle theta, if you blindly go ahead and say tan theta equal to tan inverse of minus 2, it's b over a, minus 2 over 2 root 3, you will get an angle which is negative. If you put this in your calculator, you will get a negative angle. So I don't want to do it like that. Let me find this angle. So not use my calculator. So theta equal to, let me call this thing, this angle, the angle shown. How about I call it shown angle? Okay, shown angle is equal to tan inverse of b over a, and I'm going to ignore the sign of these things. Sign means negative or positive. Okay, so it's going to be 2 over 2 root 3, and this is equal to 1 over root 3. And if you this is tan inverse, right? So that is tan inverse. Let me write it like that. This is equal to tan inverse of this, which is tan inverse of this. And if you look at that, it's going to be pi over 6. So this angle is pi over 6, but that's not my argument, because I want my argument to be between 0 and 2 pi. So I can go like that. Okay. So the argument that they want in this problem is 2 pi minus pi over 6. And that is 11 pi over 6. You cannot just blindly go ahead and put it in your calculator and say, oh, tan inverse of minus 2 over 2 root 3, because that's not going to give you an angle which is there. You have to massage it, okay? Last problem, 34, from this group. From this group, 34, same story, z equal to minus 1 plus I. Let's plot it first. So minus 1, real part is minus 1, imaginary part is 1. So there's my complex number. Okay, and notice that this is your modulus. Modulus equal to root 2. Okay, just root 2. And if you wonder where I got this from, square root of minus 1 squared plus 1 squared, and this is root 2. What is the hypothesis of that? And because I'm asked to give it an argument which is between 0 and 2 pi, this is what I want. This is the argument, okay? So theta is equal to that guy, 3 pi over 4. By the way, what that means is that the polar form of this complex number is root of 2 cosine of 3 pi over 4 plus I sine of 3 pi over 4. All right, so that takes care of this these type of problem. The last box I have to do. Now, it says, this is problem number 53. You're given two complex numbers in polar form. The first one is z1 equal to cosine of pi plus I sine of pi. And the second one is cosine of pi over 3 plus I sine of pi over 3. There's nothing wrong here except that the modulus, they didn't write it because it's 1. So this is cosine of pi plus I sine of pi. And this is equal to 1. They didn't write it. Cosine of pi over 3 plus I sine of pi over 3. Okay? So if you want z1 times z2, multiply the moduli, 1 times 1. You don't have to write it. And it's going to be cosine of this argument plus that argument. Let me write the bracket here. Cosine of pi plus pi over 3 plus I sine of this argument plus that argument. Pi plus pi over 3. So if you look at the answer in the book, they probably write it like that. They don't write 1 times 1. You just leave it like that. Cosine of 4 pi over 3. I sine of 4 pi, this is a plus I sine of 4 pi over 3. I think and then it says find z1 over z2. z1 over z2. Well, all you do is you take r1 over r2, but these are both 1, right? Times cosine of, subtract the argument. So it's going to be pi minus pi over 3. Plus I sine of pi minus pi over 3. Let's clean it up. So this is equal to cosine of 2 pi over 3 plus I sine of 2 pi over 3. Okay. And let's do number 54, and that wraps up this homework. Number 54. Same type of story, except that z1 is equal to cosine of pi over 4 plus I sine of pi over 4, which incidentally means that the modulus is 1. They didn't write it, but the modulus is 1. Cosine of pi over 4 plus I sine of pi over 4. Okay? And then z2 is given to you as, I'm going to write it like that. 1 times cosine of 3 pi over 4 plus I sine of 3 pi over 4. Okay, so if you want z1 times z2, well, multiply the moduli, this times that, 1 times 1, and add the arguments. Cosine of pi over 4 plus 3 pi over 4 plus I sine of pi over 4 plus 3 pi over 4. Okay, close the bracket. 1 times 1 is 1, so I'm not going to write it. And this is going to be cosine of 4 pi over 4, which is just pi, plus I sine of pi. You can leave it like this, but notice that this is a minus 1 and this is a 0. So the answer is actually minus 1. Okay? And the last thing is z1 over z2. So you get r1 over r2, which incidentally both of them are 1. And then we have cosine of pi over 4, subtract the argument, minus 3 pi over 4 plus I sine of pi over 4 minus 3 pi, oops, oh boy, 3 pi over 4. Okay, let's clear it up. So this is cosine of minus, if you subtract this, minus pi over 2, okay, pi over 4 minus 3 pi over 4 is minus pi over 2, plus I sine of minus pi over 2 also. Incidentally, you can leave it like this, but the answer in the book, probably they're going to make this thing 0. Cosine of Minus pi over 2 is the same as cosine of pi over 2, which is 0. And this thing is negative 1. So the answer in the book, if you look in the back, if there is one, it may be like that, minus I. All right, folks, so this is the end of this homework assignment number 21. I still have to do 22, and